Welcome to the lecture series on vitamins and nutrition. As a continuation from the previous session, we were discussing about vitamin D. So today we are going to look into the details of vitamin D metabolism, and we are also going to look into some of the deficiency conditions connected with vitamin D. And also we are going to look at what all different kinds of vitamin D testing is available, and now we are going to do it, or in other words what you call it like the estimation of vitamin D, and how vitamin D estimation could play an essential role in I would call it maintaining a healthy lifestyle and also contributing in the amount of calcium availability to various tissues. So you look at this. In the previous slide we were looking at the functional aspects of vitamin D, and we were looking at how the derivatives of vitamin D in our body is able to play an essential role in calcium homeostasis, which is extremely important. Then what we call it like the immunomodulation aspects of vitamin D contribution, and then regulation of cell growth and differentiation. See, cell growth and differentiation is extremely essential. So you might be thinking how vitamin D could play a role, because vitamin D actually helps in I would say a key ingredient in regulating proliferation. So what do you mean by proliferation? Because all immune cells have a definite set of lifespan. So most of the immune cells, especially the macrophages and some of the T cells, are short lived, maybe like 2 weeks or so, and some T cells, yes, they live even for a longer period of time, years together, but some of them they go into a state of dormancy, and that way they are able to live for long. But most of these cells, after their job is done, the immune function is done, being quickly replaced by new cells, and you need vitamin D as a kind of a pulsing vitamin to ensure the essential ingredients are available for proliferation of cells. Suppose if fast growing cells, blood cells or immune cells are considered to be fast growing cells, and for these fast growing cells, if you do not have sufficient amount of vitamin D, then it becomes a problem. And then what will happen, this would give rise to a kind of a metabolic stress in the cellular level, and the cellular level metabolic stress would directly make these cells jump their metabolic role or pathway, and that gives rise to abnormality in cell proliferation pattern, and they try to defy all the control mechanisms and eventually would end up in, I would call it the cancerous state or the benign state followed by the malignant state. So you see over the keratinocytes. So keratin, I told you earlier, the alpha keratin and the beta keratin present in the skin, the horn, and all the extra top layers of the cells of the skin that give a protective covering. Sometime before, when we were looking at vitamin A, we saw that vitamin A plays an essential role in the health of keratinocytes, and vitamin D along with vitamin A plays a role in keratinocytes. So you could even find dry skin could be a symptom because of long term deficiency of vitamin D. So along with vitamin A and vitamin D, the keratinocytes are really healthy, and they are able to proliferate and maintain a very good, I would call it the proliferative status. So you see over there what we call it like the endocrine, paracrine, intracrine functions of vitamin D. So what do you mean by this endocrine, paracrine, intracrine? So endocrine refers to the hormonal role. So there is one key organ, and the organ secretes a hormone, and it's made available to the terminal structures. So there is this common portal of blood mediating the transfer of these essential components to the final target tissue. That's what we call it like endocrine. So vitamin D, almost like a kind of an hormone, has this endocrine function. So what is this paracrine function? So paracrine is basically what we consider as cell to cell communication. So one cell to the other cell, it tries to release certain chemical factors, and through that they are able to regulate the function. So paracrine function of vitamin D is also essential, and what we call it like intracrine. So intracrine is within a cell there are so many second messenger systems, and these second messenger systems essentially need vitamin D as a component. So you see over there, endocrine would be in the global level, I would say paracrine would be in the tissue level, and intracrine would be in the cellular level. So in all three levels, vitamin D plays an extremely essential role. Now you see there, this is what we have seen earlier. So you could like summarize them as normal blood levels of calcium and phosphorus. So calcium and phosphorus are the essential minerals for bone density and for bone maintenance and muscle function. So for the absorption of calcium, as I've told you earlier, you require vitamin D, and what we call it like bone mineralization. So what do you mean by bone mineralization? So most of us, we might think as bone to be something dead. Okay, it's like it's a hard tissue over there, but in reality, yeah, it's true. If a person, if you're going to like look at the bone of a dead person, it's okay, it's dead. But when we look at our bone is actually a live tissue. So what we call it like bone mineralization means what? Bone mineralization refers to what you call it like the amount of calcium going inside the bone and amount of calcium leaving outside the bone. So that way you could consider calcium movement inside and outside the bone is a dynamic function. So what do you mean by dynamic? At any given time, the amount of calcium goes inside the bone and amount of calcium goes outside the bone remains stable. So this is part of calcium homeostasis. So you could consider bones being the reservoirs for calcium and makes the calcium available for metabolism, and at the same time when the calcium is being utilized by muscle and by other structures, the calcium can again be released from the bone. So there is a very strong correlation. Now vitamin D helps in absorption of calcium and makes this calcium go to the bone and be available to the bone, and from there it's able to really make the calcium available for muscle. So this is like three-way. So calcium from the gastrointestinal tract goes to the bones, and from the bones it goes to the muscles, and this is actually maintained in a dynamic way, and vitamin D plays an essential role in doing this. Without this, what will happen? All the calcium in the bone would now be depleted slowly, and as the bone releases calcium for the metabolic need of our body, and if bone is not being replenished by calcium, eventually the bones will start becoming weak. And you see here, vitamin D is extremely essential in maintaining this metabolic function. So that's why, as I've told you in the previous session about calcium homeostasis, we are considering the amount of calcium being available in circulation from the bone sources is being regulated by vitamin D. Now you see over here, I want you to be familiar with these two words, what we call it like rickets and osteomalacia. So what do you mean by rickets? So rickets we find in children. We are going to shortly look at what these rickets are all about, and we are also going to look at what we call it like osteomalacia. Osteo refers to bone and malacia refers to softness. So the bone becoming very soft or brittle. In case with rickets, especially for children, this is one of the highlight of vitamin D deficiency in children. See, children's, the bone is not hard yet, the bones are still growing, the what we call it like hypophyseal ends of the bone. So you could consider the hypophyseal end of the bone is that part of the bone. Maybe I would go a little further to the slides even as I am going to explain. I will come back to this. What we call as the what we call it like the tip of the bone. So this is one of the problem connected with, can you see over there the symptom of rickets here? So you see there the bones of children are basically very flexible. So when bones are deprived of calcium availability directly linked with vitamin D deficiency, so the bones don't break or crack, rather they snap like a kind of a bow. So what we call it like bow shaped bones. So this appearance of bow shaped bones, or I would call it like elongated bones which are very weak and they are very flexible to bend, is what we call it like rickets. So you see that this is the case of rickets in children, and for osteoporosis you see over here. So you see this example of a woman suffering from scoliosis. So scoliosis is basically a phase where the bones, especially a vertebral bone, gets stooped down, bent. You not normally find this for elderly women who suffer from osteoporosis. Although osteoporosis is a condition connected with estrogen insufficiency, connected with menopause and other conditions, a very early onset vitamin D deficiency can actually make osteoporosis appear even in adults, even when they are healthy. And together with, I would call it as the metabolic changes, osteoporosis could be extremely a risky affair. So you see over there, the bones start losing the mineral calcium and the phosphorus, and eventually they stoop down, and what happens is basically there will be spontaneous fractures, and spontaneous fractures is an essential component of osteoporosis. So as the word says, porosis is like porosity of bones. Since adult bones are completely mineralized, the hypophyseal end, all the long bones have at the tip of the bone what we call it like hypophyseal end. So hypophyseal end of bones are basically sealed in adults, in the sense complete calcium deposition would ensure the bone length is fully made solid. But in case of children, the hypophyseal end will not be sealed, and that's one of the reasons children, as they grow, the bones will also grow until a point would reach in their adulthood where the hypophyseal end of the bone would get completely covered with calcium, and then it stops the growth. So for children it leads to the flexible bone which bends up and gives rise to rickets, and for, I would call it like adults, it leads to porosity of bones, what we call it like osteoporosis. Both is a result of vitamin D deficiency. So you might think whether calcium deficiency can also give rise to these conditions. It's true, calcium deficiency can give rise to these conditions. So you may even ask a question whether people can have calcium deficiency independent of vitamin D deficiency. It's possible, but in any case calcium deficiency normally is associated with vitamin D deficiency. So whatever you consider as calcium deficiency can be always related with vitamin D deficiency, because vitamin D deficiency is what we call it like the precursor. So the question was whether people can have calcium deficiency independent of vitamin D deficiency. It's possible, but vitamin D deficiency is basically the precursor for calcium deficiency. Until otherwise they are going to have a abnormal pathology of calcium, it's always associated with vitamin D deficiency. So now you understand how the severity of vitamin D deficiency could be there. So it can lead to rickets, it can lead to osteoporosis, and eventually rickets and osteoporosis would not only lead to physical deformation in the children and adults, and it will lead to spontaneous fractures in these people, and eventually that could give rise to lots of other complications as well. So we have been looking at other aspects. Now we are going to look at little more components connected with the deficiency of vitamin over a period of time, and how do we like really regulate the amount, I would say the amount of vitamin D being made available for people. So you look over here, so from like gamete to grape, so vitamin D is associated with human health. Right from children to old age, you always need vitamin D, sufficient doses of vitamin D for healthy immune responses, for healthy bones, and for the normal functioning of muscles. It's completely essential. So you see over here, this picture tells you the actual requirement. So over a period of time, you see over here, we start with like in the adult life, you have 600 units, what we call it. Then as it goes up over here, you have almost like 800 units requirement. So this is one vitamin, I mean among many vitamins. The need of these vitamins basically increase over a period of time. We should always understand vitamin supplements are generally required in the early stages of development, because tissues as they grow need vitamins for function. But as we go into adulthood, and once our body gets into a settled state, we need to have standard dosage of vitamin for maintenance and tissue repair. But as we age, the amount of vitamin needs also double, because there is more amount of tissue repair happening, and all tissue repair involves metabolic functions, and we need, or we start, what do you say, there is a deficiency, internal demand based deficiency created in the physiology. So that is why you see over here, compared to the early stages to the late onset stages of, I would say, geriatric conditions, the need for vitamins basically increase, and especially vitamin D requirement increases. So we should always consider vitamin D. Not only in the early stages there is a demand, but as we age, the demand for vitamin D also increases. So you could consider, if a person is probably used to take a less amount of vitamins at a very early stage, I would say vitamin that is required for the normal maintenance of the physiology, and if they continue to take the same supplement over a period of time, I would say through the dietary sources, natural or through fortified sources, but as the demand increases, eventually if they don't modify the amount of dosage that they take, they could end up in cumulative vitamin D deficiency. One more point we need to consider when we study about nutrition and the concern of vitamin in nutrition, because as people age, the amount of intake of food taken by people also reduce, because their overall metabolism comes down. So considering the reduction in metabolism and reduction in the overall intake of food, and in that the proportion of natural foods available with vitamin D will also be less. So but you see over here the pattern, there is an huge demand, an increase in the demand. So the food intake gets decreases and the demand increases. So eventually almost every adult would go on to a phase, what we call it like cumulative vitamin D deficiency. So that is the reason we always encourage the geriatric population to supplement themselves with fortified foods, or at least with vitamin supplements, especially rich in vitamin D, to ensure there is an adequate supply of vitamin D for their function. And as I told you earlier, since they play an essential role in the cellular proliferation and maintenance and tissue repair, any deficiency on a cumulative note could be hazardous for the elderly. So you see over here, this is a brief component, we have already seen this, but here you find typically I would call it like the international units. So you see 100 grams of egg, so you have like 871 international units. So you have you say sea fish, you have a very good amount like 700 units. So you see mushrooms, so you see people who are on vegan diet have to like really take multiple sources to compensate for the vitamin loss. You see generally the food meat sources, you have more amount of vitamin D, whereas you come over here, you look at mushroom, the cereal note, the butter and the processed foods. So you see over there, and again as you go back, you look into different varieties of formula, the almond milk and the soy milk, you find the components of vitamin D levels are little higher compared to the vegetable sources. So for people who are on a vegan diet, have to have a balanced diet incorporating a wide variety of food to compensate for the lack of natural vitamin D inherently present in these foods. So maybe if they are vegetarian, as you call it, like they take only egg, so they could like really help themselves with more amount of vitamin D. So for people who have a balanced diet, who are not like having a fancy for veg or non-veg related foods, you don't have this issue. So you could get a wide variety of food, and probably you won't run in a long-term deficiency of vitamin D. But what we call it like the fortification of food plays an extremely essential role, because in your food processing, what you are going to study in the later sessions of your I would say courses, why there is a need for vitamin D fortification would be always a question for you. Now you could understand and relate this as a basic lesson, why vitamin D needs to be supplemented in most of these fortified foods. And although we could supplement ourselves from a dietary sources, but eventually the demand is more and the amount of food intake that people consume over a period of time gets decreased. So this kind of an idea about the availability of vitamin D in a variety of food would help us in balancing or choosing the kind of food that would help us in restoring the loss of vitamin D. So you see over here what we call it like where exactly vitamin D plays a role. So this is a very important question. So what we call it like vitamin D receptors. Okay, so most of the vitamins, I want you to consider all the lipid soluble vitamins actually have receptors to work with. Most of the receptors for the lipid soluble vitamins like vitamin D are present inside the nucleus. Being lipid soluble, they can go inside the cells and they can bind with certain regulatory components, and they could actually have a role to play on giving signals for cell proliferation. So that's what is very essential. What we call it like vitamin D receptors are basically nuclear receptors. So these nuclear receptors are primarily extremely important in really regulating the way cell proliferation happens. So you see over there through nuclear receptors. So if you look into the cells inside the cell, you find there are many pathways associated with upregulation and downregulation of cell signals, and vitamin D receptors play a key role, and vitamin D binding to these receptors would ensure that there could be a signal for upregulation and downregulation of vitamin D related functions. So you see there NK cells, natural killer cells, their activity. So natural killer cells are extremely important in cancer regulations, because most of the cancer cells, you know, are scavenged by, cleared by natural killer cells, because most of the cells which have gone into a cancerous state will try to mask their recognition by immune cells by not making any receptors on the surface. So natural killer cells are key in identifying those cells which are down-regulating the surface receptors and going behind them and destroying them. So vitamin D can have a regulation of proliferation of natural killer cells through vitamin D receptors, and through that it tries to, I would call it, have a impact on the regulation. So you see there is one more component, what we call it like cathelicidin. So this is one more component. More of the regulatory pathways we are going to see in the future sessions. Right now I want you to be aware of how immunomodulation of immune cells happen. Now when we are talking about vitamin D deficiency, yes, I have told you about rickets and osteomalacia, and you should also consider the dental health. So when you say calcium and phosphorus being reservoirs in variety of structures in our body, including bones and teeth, so calcium deficiency would also give rise to weak teeth, okay, could give rise to can be more propensity of dental caries and other related associated conditions connected with dental hygiene can also be connected with vitamin D deficiency. So you see over there, so this is something of notice. See, it's a epidemic. What we consider as vitamin D deficiency on a long term basis, although India is a country in the equatorial plain and we have plenty of sunshine, but you see over there, because of cultural limitations, maybe people who cover their faces, or probably culturally we cover ourselves completely when we go out, so that could prevent the amount of exposure that we can have for sunlight. So any deficiency in sunshine over a very long period of time can give rise to a kind of an epidemic state vitamin D deficiency. So you see over there, so we are recommended to check the levels of 25-hydroxy vitamin D derivative metabolite products in circulation, and we estimate them and we try to understand how we can fix this condition. So you see over there what we consider as ICMR recommendations. So ICMR has strictly given a recommendation, RDA recommendation for vitamin D, and especially for people, the target population being children in the rural and urban populations, where vitamin D levels have been constantly monitored, and also you consider the amount of vitamin D intake being doubled during gestation, during pregnancy. So this could have a long lasting effect. It could affect in the fetal development. So that's why vitamin D deficiency is considered as an epidemic. Maybe if you consider people who have adequate access to healthy food, okay, they might have supplementation, but majority of the population, that's not the case. In spite of having plenty of sunshine, we could still suffer from, or we still suffer from this vitamin D epidemic. So you see over there, what could be the reason, the dietary reason for vitamin D deficiency. So as I've told you here, vitamin D synthesis is affected, probably skin pigmentation. Okay, so maybe people have this habit of applying UV protectants, UV light protectants when they go for sun. Yeah, that's true. Direct UV can also trigger skin cancer, but I mean a periodic blocking for the healthy dose of UV, the early sunshine exposure, can give rise to decreased vitamin D synthesis. So then, as I've told you, the vegan diet, we have already seen the supplement amount of vitamin D that could be made available is less. So people who are on a vegan diet, who are not taking a balanced vegan diet, can actually suffer from vitamin D deficiency. Then as I've told you, as we age, our demand for vitamin D increases, and people who are institutionalized, who are hospitalized, who don't have access to sufficient amount of vitamin D, eventually end up in deficiency. So you see there, there could be additional need during gestation and lactation, where women need to make more of vitamin D to be spared for the growing infant. So that could always be a problem. And this is very interesting, what we consider as malabsorption. So what do you call it, malabsorption? Maybe the person is taking sufficient, probably, diet of vitamin D rich sources, but there could be some kind of problem connected with the alimentary canal, the gastrointestinal tract. Celiac disease is one condition. So celiac disease is a condition where people have allergy to wheat or gluten related components. So this actually damages the gastrointestinal tract, especially the gastrointestinal villi, and this in turn can result in the absorption of vitamin D. And celiac diseases is one of the diseases connected with allergy related malabsorption. So as well, you could have pancreatic insufficiency. So cystic fibrosis is an autoimmune disease. So we are looking at certain cases where there could be problem in the amount of bile available in vitamin D. So if you recollect, we have seen the structure of vitamin D resembles the structure of cholesterol, and cholesterol, being a lipid soluble compound, has to be sequestered, or I would say should be converted into a emulsion based format, and this would help us in sufficient amount of vitamin D available for circulation. So we will continue this in the coming sessions, more about vitamin D deficiency, the etiology, and we will look into different aspects of diagnosis of vitamin D.